Hi students, in this video we're going to look at probability tables. So after watching this video you should be able to construct probability tables to display outcomes of a two-step experiment. You should be able to understand the difference between replacement and not replacing items and the impact that has on probability, and then calculate the probability of events using a probability table. So probability tables can be used to list all outcomes of a two-step experiment. Now, probability tables do have a limitation. They can only be used for two-step experiments. Right? That's because when we do our table, you'll list one event on the top and one event on the side. It's hard then to get another event written in, somehow making like, I don't know, a probability cube. I don't know. But really, it's only best to have a probability table with one event on the top and one event on the side. Now, if replacement is permitted, then outcomes for each selection can be repeated and happen again. If replacement is not permitted, then outcomes can't be repeated. And this has an impact on us calculating probability of events if there's replacement or if there's not replacement. So let's do an example of creating a probability table. So we've got a bag of marbles that contains 3 red, 2 blue and 1 green. And then 2 marbles are selected with replacement. So that means the marbles we take out, we put back in. Now let's create a probability table listing all of the possible outcomes. Now with our table, what we're going to do is basically write each outcome in each cell. So where you've got R at the top here and R here, we can write RR in that first cell, and so on all the way across. So we can fill out our table with RR here and all the way through. This bottom left one would be green, green, and all the combinations in between. Now we want to determine the probability of selecting 2 reds. So what we're going to do is find all of the 2 reds in our table. There's 1 there, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 outcomes that have 2 reds. And then the total number of outcomes we've got here is 6 this way, 6 this way, so 36 total. So 9 out of 36, or 1/4. So there's a 1 in 4 or 25% chance that we'll pick out 2 reds. Now picking out 2 marbles that are the same color. So the probability that our colors are the same is going to be, well, we could have all of our red reds, which we've already found, but including some more, we could have blue, 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 and we can also have green, green at the very bottom here. So the probability of getting the same colors, we've got 9 red reds, we've got 4 blue blues, and 1 with 2 greens, so that'll end up being 14 out of 36. Simplifying, dividing both by 2 is 7 out of 18. Now our last one, find the probability that 2 marbles are different colors. Well, that's the same as saying the probability or the complement of them being the same. So them not being the same, or the complement, we can just work that out as saying 1 subtract the probability that they're the same. And that makes sense. If we've got the probability of them being the same, then whatever probability is left over out of 100 should be the probability that they are different. So that'll be 1 subtract 7/18, which ends up being 11 out of 18. All right, let's do the same example now, where instead of having with replacement, we don't have replacement. Now, before we fill out our table, we have to make sure we write that we can't, and include the fact that we don't replace our marbles after we take them out. So if we pick this first red marble with our first pick, we can't pick it with our second. So in that cell, And in all the other cells in that diagonal, we can't have those events happening. So we can't pick out a green and then pick out another green because we're not putting the marble back. And then once we put those crosses in there to say those events can't happen, we can fill in the rest of our table like we did for our previous example. Now notice this time we don't have 36 events. Right? We still have the 6 this way and 6 this way, but we're taking out 1, 2, 3, 4, 5, 6 events. So we only have 30 possible outcomes this time without replacement. Now let's do it again. The probability of finding 2 reds, probability of R and R, is going to equal, we've got 1 red there, 2, 3, 4, 5, 6. So our probability of getting 2 reds then is going to be 6 out of 30, or 1/5. So notice there, students, that that value is different to what it was before. Previously we had a 1 in 4 chance of getting 2 reds. Now it's only 1/5. So changing the fact of whether we have replacement or not does affect our probability. So let's find the probability that our marbles are going to be the same color. We've done all our red ones there. So our blues we can get with here, there's blue there, blue there, and we can't get 2 greens now because once we've taken that green out, we're not putting it back. We can't get another green out of there. So our probability then that our marbles are going to be the same color, we have 6 that are red, and 2 of them that are blue and blue, out of 30, so 8 out of 30, or 4/15. And once again, that's different to our previous value, which I think from memory was 7/18. So again, changing the fact of whether we have replacement or not does affect our probability. Now, getting 2 marbles that are different colors, so we can do that the same as before. That's the same as our complement of the marbles being the same. Right? The opposite of being the same is that they're different, so that's our complement. So 1 subtract 4/15, which will be 11/15 for that one. We could have also gotten that value just by counting up what's left over here. So we've got 9 here, another 9 here, is 18, and then the remaining 2 is 20, 22. So that's 22 out of 30, which is 11 out of 15. So we can just add those up and use our formula anyway, or use the complement. All right, so after watching this video, you should be able to construct a probability table to display the outcomes of 2-step experiments in both replacing situations and non-replacing situations, and then use that table to calculate probability.